Assalamu alaikum, ladies and gentlemen. Welcome back to another live stream. So this is part 2 of me trying to make a chat app using Godot, async, Rust, and C# live. Okay, so please join my Discord server. You can find the link in the description. And let's go. So yeah, he says, mate, welcome back to the live stream. How is it going, mate? How is it going? Alrighty. So last live stream, unfortunately, I was confused by some Tokio channel stuff, right? So we couldn't really get anything working. Like, you know, I finished, well, at least like a little demo of a chat app, but I actually figured out what was the problem. I was just confused about channels. I thought I was having, like I was working with MPSC, so like multi-producer single consumer channel, which is in the Rust standard library, but I was actually working with the broadcast Tokio channel, which actually supports multiple consumers and multiple producers. So that confused me a bit there. That's why it didn't go well. But yeah, I figured out off camera, but I actually reverted to whatever I had in the first stream, so I could actually show you how to actually do it. But yeah, so yeah, let's get going. Let's go to the Rust code. So I think this is what we had before. I'm not sure if it's exactly the same thing because I tried to revert it, but it should be something similar. Okay. So first of all, I'm not going to be storing any messages for now, at least for now. And well, broadcast channel is exactly what we want. It's a multi-producer, multi-consumer broadcast queue. Each sent value is seen by all consumers. So I was actually on the right track. I was just confused. But anyways, so this RX here, I'm not gonna need it. I'm just gonna drop it. So like this RX is for the server to be able to receive messages to, but for now at least we're not doing anything with the messages in the server. So I'm just gonna drop it so it doesn't keep the channel open. So okay, cool. So here we have that, and the other thing is that this ADDR is not the correct ADDR of the client. This is the actual client ADDR or address, basically. So client ADDR, so that was wrong. Second thing we have here, tx.clone, that's good. So basically every client gets sender a tx. So and we also, every client needs an rx, and to get an rx you actually say tx.subscribe. Okay, cool. The other thing is we have Tokio spawn. Okay, so we got message, loop, message clear, writer, and honestly I'm not going to be using buff writer. I don't really need it in this case. Since every time I have to flush and grab like that, so no need for now at least. I won't bother with that now. And what else? Okay, so hello Theo Paris, our admin. Welcome back to the live stream. How's it going, man? Client ADDR. So client ADDR there too, probably, yeah. And the other thing here, tx.send message clone in wrap, which is correct, right? Now the thing is, after we send our message, we also want to receive the messages that we got from the other clients, and we can do that through the RX. So what we could actually say, basically, so this is basically like the loop of the client. So we can read some lines, and then we can try to receive some messages, right? So exactly, good job, Copilot. Let's go. Well, let's okay, message equal to rx.receive, and of course let's make rx mutable. So rx.receive, so this would basically go ahead and try to receive a message. And it's gonna wait for it, of course. Receive the next, yeah. Well, actually, no. Hold on. Anyways, whatever. So we're gonna try to get a message. Then we don't need a buff writer. Just go to, well, do we? Hold on. Yeah, no. Let's just use the writer directly, actually. So writer writes all, and we don't need flush because we're not using the buff writer. So that's good. And we need the async write ext trait to be able to use that. So basically this guy right here, sorry, this guy, and I don't need the buff writer here anymore. And now what's up? Cannot borrow immutable as make writer immutable. Okay. And now what's next? Okay, so this should actually work, though it does have a little problem that we're gonna fix in a second, but let's see if this actually works. So let's launch our server. Oh, let's see what's up. So client EDDR, please. What? Okay, try this. Okay, server started. Great, perfect. Now let's try to run some 2 clients to test this out. And let's see what's up. So as you can see right now, it's actually correct. So every client have its own port. It's connecting from its own port, basically. So that's perfect. Let's get the second client. Okay, so let's say, well, hey. And yeah, we got, oh, what the heck? Hold on a second. Why this UI is broken? What? Weird. What if I say hello here? Okay, good. So you can see that I actually did get hey, right? But it's kind of broken. So I only got it when I sent the message. Why that's the case? Because here I'm actually only listening for messages, or receiving messages after I get a message, after I read line. Okay, so that's not great. What we need is to actually asynchronously write messages, like wait for messages from the user, but also wait for messages from the other clients at the same time, so asynchronously, right? So this is where Tokio comes in handy. And I'm not sure why the UI is broken, but we'll see about that later on. Okay, let's see what's up here. So what we're gonna do, basically, we're gonna use something called Tokio select. Tokio select. Now, I don't know what the heck this is talking about. Anyways, let's go result is equal to buff reader, exactly. So we're gonna use the select, and basically the select, it's like a match statement. You can actually give it multiple branches, and it would pick any branch, whatever happens first. But basically they would run like asynchronously, right? So that's great. That's what we want. And result Rx, exactly, perfect. And we don't need this anymore. Let's keep buff reader, Tokio select. So basically, well, hold on a second. Result hue size. Salim, welcome to the live stream. Going to sleep but found you are alive, so salam. Thank you for coming to say hi. Maalaikum salam, by the way. And yeah, good night. Thanks for coming in. Okay, so if result in wrap equal to 0, then break. Alrighty. Otherwise, we're gonna get a message. Okay. Well, actually, we could basically say this. Okay, message, I believe. Yeah. And we don't need this anymore. So this would only work, or would only run if we got an okay message from receive. Okay. So I write all message as bytes await in wrap. And I think that should be good to go. Probably. But yeah, after we read line, what we need to do, we could actually send that message. Well, what the heck I'm talking about? Hold on. tx.send. No. What I want to do here? Yeah, I want to send it to the other clients. So that works. That's perfect. Is there anything else? I don't think so. Anyways, let's try this out. Let's see how it goes. Server start. Let's launch to clients. By the way, is there anyone open for testing across the internet here? So like I could give you the application and then we can test together. But yeah. Hey, and as you can see right now we actually received a message directly. Hello. Okay, you see, so it perfectly works. And here, by the way, we're not actually storing the messages in the server, as you can see. In fact, the RX, if you want to store the messages, let's say, because right now what happens though, if I actually, well, hold on, let me make sure to quit this. Let me just launch the launcher of Godot. Let's say I ran one client, okay? So the one client, oops, that one client, well, where is the, oh, it's not running. Okay, let's go. So server started. Okay. Why didn't, oh, because let me try to launch it again actually. Run. Okay, so we have one client right now. So we could actually send messages, fine. Oh, actually, that's probably gonna end up in a little problem here. What happens when there's one client sending messages, but there is no one to receive those messages, and we have a capacity of 10 in the channel? I think it would actually hang. Let's try to send 10 messages. Interesting. What? Or maybe there is some mechanism in place to, so like if there's no receivers, then it would just, I don't know. That's interesting. I thought I would actually hang it. Weird. Anyways, whatever. Now, what's my point is, if we actually right now run another client, we're not going to receive the old messages, right? Because of course we're not storing any messages in the server right now. But remember that we do also have, yes, we have an RX for each client, but we also have an RX for the server itself, which we're just dropping right now. But instead of dropping it, we could actually use it to store messages. So let messages is equal to vec new, and then we could basically, okay, so we don't want to like block the thread here. We want to actually proceed to this loop where we're actually accepting connections and so on. So what we're gonna do, we're actually gonna spawn a new task, right, or a new feature. Async move, yeah, async move, exactly, cool. And we're gonna loop. We're gonna try to receive a message, basically. So, or in fact, let's just say while let OK message is equal to rx.receive, and of course rx should become mutable right now. Receive await, then every message we get, we're basically gonna push it, and we're gonna make this mutable. We're gonna push it to this vector, and notice that we don't need any arc or mutex or whatever here, because the actual communication between the tasks is done through the channel, the message channel. So we don't need that. This vec is only being used by this specific future, okay? So we don't need any like multi-threading synchronization stuff here, which is cool, pretty perfect. All right, now the thing is, after each client gets connected, we need to replicate the original message, like the old messages to it, right? So the stored messages. So how can we do that? Good question. So before the client loop, I think we could probably go ahead and see what we could do here. So we're gonna go through all the messages. Well, actually, the thing is, we could yeah, so I see the problem. But honestly, let me just go with this one. Let me just go with this so we can see the problem. Then I'm gonna fix it, so you could actually see what's the problem here, instead of just me dreaming of it. Yeah, let's go. So for every message in messages, we want to basically go ahead and write all to the client. Now the thing is here, use of moved value messages, because this messages here is, you know, moved to this task, because this is an async move block, right? So that's not gonna work. So to actually do that, we need to make this through an arc. So both tasks could actually share the ownership between them, right? So let's make an arc here. So this is like a thread safe reference counting pointer. Arc stands for atomically reference counted. Okay, so there you go. So this is like a shared PTR in C++ if you're a C++ guy. But there you go. Okay, cool. Now we actually need a different reference for every single client. So messages is equal messages clone, though I actually prefer to say arc clone instead, like this. It's kind of the same, but this is more like more clear what's happening. We're actually cloning the arc, not the messages themselves here. So that's great. The other thing is, yes, right now we don't have that problem of ownership anymore with the borrow checker, but we have another problem. This messages here doesn't implement into iterator. So we could actually try to say messages iter, but then that becomes a problem. Borrow of, what the heck? Hold on. Oh yeah, borrow of moved value. So the server also needs its own reference. So server messages are clone, and then here we gotta use it. Otherwise, it's gonna be consumed by the server thread or server task. So server messages push, and let's make this mutable. And what's up? So the other problem that you're gonna see is we cannot borrow data in arc as mutable. Okay, because arc is immutable, right? So what we gotta do, we gotta use some mutex to actually synchronize the mutation here. So let's actually also use a mutex here. Mutex new. Let's import this guy. So there's two kind of mutex. There's the standard library one and there's the Tokio one. The Tokio one helps you to actually synchronize between awaits, like on await boundary, which is kind of hard for me to explain right now without an example. But like mostly you would just want the standard library one pretty much. So we're just gonna go with the standard library one. So arc new mutex. Actually, instead of mutex, I'm gonna go with RW lock. And you're gonna see why in a second. So of course the standard library RW lock. So mutex actually gives you ownership and no other task could access that resource anymore. But RW lock actually allows for multiple readers at once. So basically what's gonna happen here is that multiple clients may need to access the messages to read them, right? From the server, but like, which is fine. So like if multiple clients are reading some resource at once, then it's fine. But if there's a writer, it would be like a mutex. They would take explicit ownership of the resource at that point, right? But anyways, enough of talking, I guess. Let's actually lock the server messages. So, well, not lock. Since we're not using mutex, we're using RW lock. We gotta say write, because here we need write access, right? So, yeah. Well, let OK message. Consider using to unwrap. Yeah. So this could actually put an error if like the other tasks that are holding the lock, if they got poisoned. So this function return an error if the RW lock is poisoned. An RW lock is poisoned whenever a writer panics while holding an exclusive lock. An error will be returned when the lock is acquired. Anyways, so I don't need mutable access anymore, by the way, to messages. So this is actually using internal mutability, since we're using an RW lock and so on. But like, sorry, an arc. But anyways, let's go ahead. Now here, this is an interesting problem that I've actually gone through. It's not an iterator, yeah. Make it into an iter, and what's up now? Well, first of all, we actually gotta lock it, so we need read access. Iter. And the current scope. What do you mean? Hold on. Method not found. No method named as bytes found for reference. SCD RW lock. Interesting. Weird. Yeah, we got a read guard. We should be able to actually access. Huh, interesting. Weird. What if we clone? No. Weird. What if I say into iter? I don't think that's what I want, yeah. Okay, let's just get the messages locked first. So let reader, well, anyways, messages read, and oh, I see. So I gotta unwrap. Damn, I see. Yeah, okay, that makes sense now. We don't need clone for now. Okay, so this is the error that I was talking about. So there's gonna be some interesting error that I've seen before. So future cannot be sent between threads safely, and you're gonna get this crazy error here. Future created by async block is not send. And I was totally confused what the heck is going on here. So has type RW lock read guard, which is not send. Await occurs here with messages.read.unwrap may be used later. Now in Rust, it's like in C++, it would just leave you do anything. Doesn't care, you know, it's like just shoot yourself in the foot. But here we don't do it. We don't do that here. So like the compiler will deal at you every step on the way. So the problem that we have here is that we're using await. So here, first of all, we're getting the lock. We're getting the read lock, right, of the messages. And every iteration we're actually awaiting on that thing. The problem here is that we acquired the lock in one task, which could be in a different thread. And so when we await again, we could, like, this task could be transferred to another thread. So it would run on another thread, and there you go, boom. You have screwed it, right? So that's problematic. Now here we could probably, this is the problem, by the way, that we could maybe use Tokio RW lock instead of the standard library one, I think. I haven't tried it though. Actually, let's try it now. Why not? So how are we gonna do this? So where's RW? There you go. Okay. So instead of getting it from the standard library, let's try. I haven't tried it actually, but let's see. Tokio sync. So I'm using the RW lock of Tokio now. And we gotta actually await this now. Okay, and what's up? Okay. What? Let's try this. In wrap. Method not found in impl. Oh, I see. So server messages. Have we changed anything here, or what the heck? Oh yeah, await here now. And it seems like we don't have in wrap for some reason. And is it? It seems to be compiling. There you go. Okay, so if you use the Tokio one, you can actually get away with this await, like, you know, like basically locking some synchronous resource and then basically awaiting with no problem. But honestly, I don't think it's worth it. I don't know. I'm not an expert at this. But I would honestly, for now, I think it's probably okay to just go ahead. So let me see. And instead of doing this, we could just like clone the whole messages, right? So get the read lock, then clone all the messages to the client, and there you go, done. So we don't have to hold the lock on every iteration, right? So let's see. So let messages equal to messages dot read dot inwrap and then dot clone. So we get read access, and then we clone the vector. We clone all the messages, and then we could, you know, freely go ahead and basically iterate through all the messages and then write them all, basically. So yeah. Now here we're gonna have though a little problem, I think. But yeah, let's see if this actually works first of all. Variable does not need to be mutable. Let's remove this. Okay, now let's run the clients. Let's go. Hey, and we got hey, hello. Now what if there's another client connected? Will they get the messages replicated to them? So let me run another client here, and there you go, we got it. But we have a little problem. We got these two messages in one message, right? Which is to be expected, because we're relying on a new line to like stop the bytes reading off from the socket. So that's not great. We actually have to fix it. So yeah, let's go with that, I guess. Let's try to fix it then. So instead of relying on a new line, we would actually better up relying on something similar to HTTP, where like you have the message length and then the message content. So like you would say how much bytes you're expecting in this thing, and then it would have to wait until it completes that message. That would also help us when we're gonna hopefully implement you know, multiple message types, because like I'd like, if possible, I don't know if I can yet, but I'd like in the future or in a future stream to actually implement more message types, not just text. So like even let's say images, voice, video too, maybe. Well, we'll see how it goes. Okay, so alrighty, so where are we even gonna start with this? Good question. By the way, another thing that I wanted to mention, instead of vec for the server messages, well, where is it? No, the messages here. Instead of vec, if you want, let's say for the server to only store, let's say 1024 messages or whatever. So like just end messages, and then afterwards it would just keep like remove the old messages. And yeah, if you want that, you could actually use a circular queue, like Rust circular queue, I think. And there you go. And this is also helps you to actually, so like a vec needs a heap allocation, but a circular queue, since you already know the capacity that you want, it's just on the stack, which is great. So a circular buffer like queue is created with a set of capacity, then items are pushed in. When the queue runs out of capacity, newer items start overwriting the old ones, starting from the oldest. So yeah, let me show you how you could actually use this. So it's interesting, I guess. So cargo add circular queue. No CMake got harmed today. Let's go. There you go, done. Now let's make a circular queue. So we're just gonna go ahead. We're gonna say, circular. Yeah, with capacity. And here you tell it how much messages you want to save, right? So once you have more than 10 messages, it would start overriding the old messages. And there you go. Now, what's next? Circular queue. is not an iterator. That also means that when we're gonna like clone the messages, we're not gonna make another heap allocation. We're just gonna clone that stuff in the stack, I think. Tray iterator is not implemented for a circular queue, which is required. Okay. So I think it doesn't have into iter here. Okay. So can we say iter then? Okay, cool, lovely. So we just had to do iter, I think, there. And I believe that's it, pretty much. Yeah, that's basically it. And let's go. Now, let's actually, instead of 10 messages, let's say 2 messages. Oopsie, it's not there. That's the channel here. Okay. So let's do this. And let's basically run it multiple times now, multiple clients. Let's go. So we're gonna say, hey, I don't know, hello. Okay. So we have these 4 messages. Now let's say there's another client connected after all those messages. Yeah, let's run another client now. And there you go. We only got the 2 last messages, subscribe and haha. So yeah, that's interesting. Okay, cool. What the heck? Why it panicked? I guess because kind connection reset. An existing connection was forcibly closed by, yeah, I see. So actually, instead of result in wrap, I would probably go with OK, honestly. So OK, message, I think, or no, length. So would that work? Yes. And here, instead of this, we're just gonna say length is equal to 0. So basically, when a client actually disconnects while we're trying to read line, then we're basically just gonna ignore it. So we're only gonna, process the thing when it's okay, and not when it's error. Okay, what's she gonna do next now? Good question. Yeah, let's actually start implementing that messages stuff. So let's see, where are we even gonna start with that? So socket write on messages bytes. Okay. By the way, why are we using socket here? Yeah, because we don't have a writer before. I see. Oh, by the way, we can actually split this. We don't have to do this here, I believe. Message clear. Yeah, I think we could probably just do it somewhere around, I don't know, here. Yeah, so we don't have to do it like every iteration, Wasted CPU cycles. Okay, cool. And instead of socket, now we could just use writer. Write all. Okay, so now, before we actually write the message, what we want to write, some value to indicate the size. So I guess let's go with U64 maybe. It probably should be LE, like for Little Indian, but we'll see about how it goes. I'm not sure about how C# does it. We'll see. So we're gonna send the message length. Well, not the length though. Can I get the size in bytes? Returns the length of the string in bytes, not charts or graphemes. Oh yeah, I mean, yeah, it's already in bytes. Okay, cool, lovely. Though we could also say, so this is the bytes that we want to send, just to make sure we're not doing anything stupid, right? We're gonna get the bytes, bytes.len, just program it defensively a bit as U64, because this gives us a U size, and then bytes just bytes pretty much, yeah. So bytes.len and right. I could probably use some crate like Surday maybe to actually make the serialization easier and the deserialization easier, but for now let's keep it simple. Write U64. Okay, where we're doing this again? We're doing it here. Okay, so we're gonna do something similar here too then. And why the heck it's not from, oh yeah, because it's in a macro. I hate macros. Okay, anyways, okay, message, and the message is not being used. Cool. Let's go with message here, and there you go. Also, I'm actually gonna call this input buffer instead, really. So how do you do that for thing again? Refactor, rename. Okay, so I'm gonna call it input, I guess. Okay, there you go. Now what? Is there anything else? TX send. Now here, same thing. So we're sending it to the other clients. And so what we... Interesting. Interesting. Actually, it's probably time to make this into a struct. So this would receive bytes. Good question. tx.send in p.clone. But how does that? But yeah, let's go to C# and actually program that client first, so we could actually test this stuff up. All right, so now what we're doing here, we're saying stream.read buffer. Okay, then text encoding gets string, and so read data from the network stream and stores it to a span of bytes in memory. Okay, I see. Then we're trying to get the string, then we instantiate the message. Okay, let's look for network stream documentation. Network stream can read, can see, can write, data length, read timeout, begin read, begin write, close, copy to, finalize, flush. Read span bytes, reads data from the network stream and stores it to a byte array. So the thing is, I'd like to actually read one U64 first, basically. So how can I do that? Stream.read U. No, there's no read U64. What the heck? I can read byte though, but there's no way, I guess, to read multiple bytes? Or is it? Actually, there is a way. So this read function is probably relying, yeah, on the buffer size, isn't it? Interesting. Read async. Read at least. Read byte, read exactly. Okay, reads count number of bytes from the current stream and advance the position within the stream until the buffer is filled. I see. Read exactly async. Right. Okay, cool. Though I want this to be optional, I think. So yeah, well, let's see how we could do this, or let's see the AI what it does. Read U64. Okay, go on. And so it used some bit converter. Okay, cool. 2unt64. Well, that's kind of clunky. I would expect C# to have something nicer. Maybe there's a library out there to do that. But anyways, so we got here the length buffer. Though instead of that, we could probably set read exactly. Maybe? No? Why there's no read exactly? What the heck? We've just seen it right now, no? Apparently there's no read exact. Weird. Well, anyways, whatever. Can I just ignore that thing? Okay, cool. So length buffer, new bytes, and then we get, I'm just gonna ignore this. Actually, hold on. Hold on. Actually, I need to keep on reading until we're done with the length buffer. Okay, so var read bytes equal to 0, right? While read exactly, but nah, hold on, what's going on? ulong, what? What? So length is ulong? Ah, I see. Interesting. Well, I use the U64 because, you know, I'm planning on say transferring files and images and so on. And that could indeed be more than 4 gigs, you know, or whatever. Well, you could make this a ulong. But anyways, bytes read. So stream.read is defined below. Okay, let's actually just ignore this. And in fact, we don't need any of this here. Yeah, like, anyway, never mind. So bytes count equal to stream.read. So we're gonna keep on reading new bytes, and then we're gonna advance read bytes with bytes count. And then finally, after we're done, then we can go ahead and get the string. And there you go. Whoops. And we could use this length right here. While read bytes is less than length. Okay. Argument type ulong is not assignable to parameter type int. Well, that sucks. How are we supposed to do this? Anyways, message instance, message scene, instantiate. Okay, I think this should possibly work. So first we read the length of the message, right? So we have a length buffer, we read to that length buffer, then bit converter to uint64. This gets a read-only span. And then we got a read bytes, how much? So while read bytes is less than length, then bytes count to read, and then read bytes plus equal bytes count. Then the message gets string. I feel like that should maybe work. But yeah, let's try it out. Let's try it out. Okay. Let's launch clients. And let's see. Well, at least it didn't hang. At least it didn't hang. Come on, bro. What's up? Okay, so clients got connected. Perfect. And now let's test this out. I'm not expecting it to work from the first try. Yep, no. It doesn't work. Interestingly, so what's the problem? Good question. Yeah. Okay, let's launch one client and see what's up there. So debug editor, run one instance, and let's try this out. Come on. Oh, it actually hanged the makes sense, I guess. It's interesting because here we don't have async, you know, and it kind of sucks. It's like, I don't know how to use C# async with Godot. It doesn't allow you to do that. So like, if you look for Godot C# async, there's nothing really interesting there. So you're just trying to do this asynchronous stuff in the process function. Okay. So this read bytes, yeah, let's do this. Okay. So private read bytes is gonna be a ulong read bytes is equal to 0, right? So we don't need this anymore. And then we got the length that we have got. So private ulong message length, I guess. So that's the message length. So now, okay. So if message length is equal to 0, I guess, then we could try to read a length, I guess. Else, we could try to read some of the message. So every frame, well, yeah, every frame we're going to try to read some of the message, basically, yeah. So that's cool. So instead of the while loop, because this would actually block, so that, which we don't want. Or I mean, actually, instead of doing that, we could like ask every time maybe if the data is available. Well, let's keep it simple for now. Let's remove this stuff. Now that's the case. And then afterwards, if read bytes is less than message length, then we're going to return. So if read bytes less than message length, then we're going to return. And after that, we're just going to say message length equals 0, I think. Right? Right. And read bytes is equal to 0. There's probably a better way to do this. But anyways, message length. Yeah. If not stream data available, return. Okay, let's see. Well, I need to actually, hold on. Come on. Bruh, what the heck? Took forever. So case mismatch opening requested file and export to other case sensitive. Interesting. Interesting. Let's go here. Message.tscn, but here what we got? Ah, I see. Okay, cool. Now let's actually try this out. So I'm just gonna go to here and I'm gonna launch the server. Yeah, it's already launched, cool. Let's run this out and see what it does. And let's go. So it did find some data available, and it's gonna check if message length is equal to 0, which is. So it's gonna try to read the length of the message, apparently. Interesting. Look at that message length. Interesting. 4-3. That's invalid. So there's two cases here. It's either that we have the wrong, like, Indian of the bytes, but yeah. Let's try something. Let's try. So instead of 2U64, we could go with 2U64LE. And let's try this out. Should probably make this into its own function. So. And let's go. Did the server run? Yeah. Let's try again and see if that fixes it. Okay. Yeah, we got nothing. Yeah, because there's no messages, right? So I need to launch some other client. Oh, but I forgot that. Okay, but let's just see what's gonna happen here. Okay, so now we do have something. And we did indeed get 4, which I think is correct. So cool. And let's continue. So now we're trying to read the message, right? So stream read buffer. We got 4 bytes, perfect. And then, so read bytes right now is 0 and bytes count is 4. So we're gonna actually make it so that it's 4-4, cool. So the message payload is complete right now. So we're just gonna reset the variables. Then we're trying to get the string, the message. But the string is apparently nothing for some reason, which is interesting. An empty string. What the heck? Why? Perfect. Let's see. Run. Well, actually, let's go to here, yeah. And let's launch 2 clients and just see how it goes, I guess. Debug, run multiple instances. Run 2. What's up, Cyberroos? Welcome to the live stream. Okay. So let's try. Oh, Rust even panicked now. Interesting. An existing connection was forcibly closed by the remote host. Okay. Here. Yeah, I think we haven't updated the code which sends the message, did we? Yeah, we haven't. Yeah, my bad. Okay, so here's the case. So we're gonna actually send the text, and then we gotta write a U64. Crap, I have to do that thing again. Damn. Okay, let's see if the AI could help here. Read the message length from string. Okay, let's see. Nah, useless. Okay, let's see what we can do here. So we're gonna have a length buffer, probably, and then we're gonna try to, well, we're probably gonna use a bit converter again. So bit converter dot maybe uint 64 to uint 64, but I want from uint 64. What the heck? How to convert a U64 to bytes in C#? Go on. Bit converter get bytes. Okay, makes sense. Get bytes, and then we're gonna give it u long. Yeah, good. So we're gonna go with u, well, 8ul, I think. Is that good enough? I think so. And what this would give me, it would give me a byte, like a byte array. Yeah, cool. So that's the length buffer. Whoops. There you go. So we got the length, perfect. Now let's actually write that. So stream.write message. What the heck is going on there? Oh, okay, I see. Length buffer, yeah, perfect. Length buffer dot length. Yeah. Okay, that seems good to me. Okay, bytes 8ul. Okay, let's try this out. So let's launch the server again. And moment of truth, let's find out how this actually works. And let's just run once. One client. Oh, I see. Let's remove the breakpoint for now. Let's go. Okay. We didn't get anything. Why? Client connected, but we're not receiving. Why that could be the case? Well, let's actually see what we are getting from the client. So read, where's reading stuff? Did we actually implement the reading though? What the heck? Read. Yeah, we're still using read line, my bad. I see. Crap. Okay, that sucks. Okay, let's read some bytes. Well, first of all, we actually have to read some u, but like how I'm gonna do that? Interesting. So like the pending. It's actually more complex than I thought, bro. We're gonna try to read. It's like, first of all, I want to read an a U64, probably LE, and then that's going to be like the length of the actual message. Okay. Let's actually forget about Tokio select for a second, so we could keep it simple. And let's just go directly and say buffreader.read U64LE await in wrap. And then we're gonna match on this. I guess, or we could just say message length, okay? Message length is equal to that, and now we could say buffreader dot read exact, I think. Okay, so let's make a vector for the message, and we're just gonna use the macro here. It's saying buffreader take message length read to string. That's interesting actually. I was gonna do something else, but that seems more nicer, I guess. Buffreader. Why the value got used? Got moved. What the heck? Why it would get moved? We're having mutable self here, not self. The heck? Buff found U size. That's interesting. Oh, take actually uses, what the heck? Why? Take consumes buffreader, bruh. Anyways, let's just go to what we had before. So vec 0 message length as U size, and then we're gonna read exact mutable message await in wrap, and here actually as bytes probably, or yeah, well, we gotta make this mutable, yeah, and there you go. So that should probably do the thing. Yeah, read exact, and then we wanna receive messages. Okay, tx.send string from etfh message in wrap. Okay, let's try this one out. We're gonna run one instance for now, just as a loopback kind of thing for debugging. And let's see. And we crashed the server. Memory allocation of bytes failed. Interesting. Could it be just U64 then? That's weird, but okay. Let's try that out. Hey, we got crashed again. Bytes failed. Huh. Okay. So no, it's probably correct. Read U64LE. Bro. Okay, let's see what's happening here. Hold on a second. Cause yeah, so let's actually do this and do, well, probably, well, let's just go with this. Yeah, fine. And let's see what's happening. No, I want to debug this. Hold on. Oh, why did it hit this guy? Interesting. Okay, let's see. Okay. Oh, it's waiting for the message length. Okay, cool. Are we gonna send hey? And let's see now. Sorry. Oh my god, I have to deal with that stupid future stuff. Oh crap. Why? Nah, this sucks. We're gonna go back to our old printf. So okay. Yeah, let's do that though. Info message length, or we could just say dbj, honestly. dbj message length and dbj, well, this is the actual string, right? So oopsies, s send s, oops, send s as dbj s here. Well, let's dbj this instead. And yeah, let's try this out. Server start. Let's try to run this. And let's go. Hey. We got a message length of 8. What? Message length of 8. Really? Interesting. Why that's the case? No way. Oh, hold on. What the heck I'm doing here? Crap. Bro. I need to go on a coffee detox at this point, man. I feel so stupid right now. Message dot length. I don't know what I was thinking when I wrote that. Okay, so here we get the message. Actually, we already got it as bytes. Yeah, I'm stupid. But hold on, no. We still need the length buffer, yeah. What? Okay, anyways, let's just try this out. Yeah, I'm super stupid. Alrighty. Crap. Let's go. Alright. Hey, and we got no hey back. Again. Alright, what's up now? Oh, it didn't dbj anything. What? Why? This is ridiculous. Oh, we have just printed it right now. But afterwards. What the heck? This is very weird. Try it again. Hello, Isai. How is it going, man? Why the heck I'm not getting that thing printed? What the fuck? What are you doing right now? Just fighting with this thing. Oh crap. So I'm trying to basically, instead of using a new line as the end character, I'm trying to send the what is it called, the length in bytes of the message and then the message content. So yeah, this is driving me insane. Oh, actually maybe it is correct after all. What the heck? I'm super confused right now. Let's actually debug this, okay? And let's see if it makes any stupid sense. What the heck? Okay, let's run the server again. And let's try. Let's see what the heck is going on here. Okay. So we got the message with text hey. Okay. And then we get in the bytes of the length. So the length buffer contains the bytes, which is 3. Okay. Then we're gonna write to the stream. We're gonna write the length buffer. So basically the bytes of the length. And then 0, count length buffer dot length. Perfect. And then we're gonna write the message itself. I mean, seems everything seems correct to me, but okay. Well, what the... I don't understand what's wrong. It should debug message length, but it's not. Okay. Yeah, it's not even... What? Hold on. So U64 is actually 8 bytes, expecting 8 bytes, right? Yeah. Oh, fuck. I see. Oh my god, I hate this. But I had the option to upload files to the chat. Yeah, I do. You see what's the problem here? Message.length is actually integer, not you long. That's why. Fuck. The as operator must be used with reference or nullable type. How the heck do you cast to long? Okay, there you go. Oh my god, I hate this. I should probably look for a library to serialize and deserialize, honestly. But any freaking way. Any freaking way. So let's run the server. It should work now. It should work now. Unless if I'm missing something again. Okay. Let's try this out. Okay, we're receiving it in the server. Perfect. Perfect. So we're getting that the message length is hey, is 3, and that the string is hey. Cool. Okay. But why we're not getting it back from the server though? That's the real question, I think, right now. Yeah. Let's go. Why we're not getting it from the server? So now we have to debug this crap. Okay, let's see. So let's run the server again. But hold on a second. We're saying tx.sendS. Send S. Yeah, let's just debug this. And see what the heck we're doing wrong again. Okay, so now we currently have nothing to read. I hate this. Okay. Yeah, that's normal. So we gotta actually run another client real quick to add a message to the server, hopefully. And yeah. But no, actually that wouldn't work. I see. So just for testing purposes, you know what I'm gonna do? I'm gonna actually add some messages to the server. So it would replicate them automatically at first. So we don't waste time. Oh, what the I'm not using Rx, really? Yo. Makes sense. Makes sense now. Okay. So. Exactly. So. All right. Write u64le bytes.length, await in wrap, and writer write all bytes.await.in wrap. Let's try now. So I wasn't actually receiving the messages in the first place, which makes sense. Let's remove this thing real quick. And yeah, let's try this. Hey. And we're not getting anything. What the heck? Yikes. Run. What? Now it actually works, but we're not getting any message. Interesting. Interesting. Okay, let's actually debug this now. We're gonna keep on debugging. Okay. But yeah, I forgot again. Oh my god. Let me So let's stop this, okay? And let's add some messages. Where is messages? There you go. So this circular queue here, messages dot write dot in wrap dot push, and we're just gonna add one message so it would replicate it basically. And write u64le, write all. Cool. So let's try this out and let's go. So this should replicate some messages from the start. So we have some data available. And yeah, cool. So now we're checking if message length is equal to 0, which it is, because we need to read the byte, the length. So we read into the length buffer. We got 5. What? Or is it? Hold on. Message length. So what is the message length now? What? So message length is 5 now, yeah. For whatever reason. Oh, because hello is actually 5. Well, makes sense. Okay. So hello, 1, 2, 3, 4, 5. Makes sense. Good. So we're actually reading the message length correctly. So if read bytes less than message length, then return. Yeah, because we don't have the message ready yet. So let's just continue to the next data from the server. So we already have the message. So we're actually going to try to read some stuff there. So we have read 5 bytes. And good. So now, I see. I mean, we should have, well, no, that's actually good. Yeah, that's good. Perfect. And now message length. I really see what's up. Fuck. I'm resetting the variables and then I'm using them. Perfect. Serialization is fun manually, but you gotta do it manually first. So. Okay, please work now. Oh my. Okay, let's see. Let's try this out. Remove this breakpoint. What's up again? What's up? Oh, maybe it crashed already or what? Weird. Let's try again. Okay, we got the message finally. Oh my god. Okay, finally it works. Oh crap. That was crazy, man. That was wild. Okay, finally it works. Now we're not dependent on the new line. We're sending the message length, then we're sending the actual message. So yeah, and this would actually allow us right now to implement multiple types of messages. So that's cool. And I don't know why it keeps on panicking. Where the heck it panics? Here. Okay, because it's disconnected, I see. So alright, let's fix that. So instead of that, we're just gonna match on this guy. And if okay, then we're gonna get the length. Otherwise error, we're just gonna break to go to the next thing. Now, do we actually need the input anymore? No, we don't. But we do need a buffer though. Right now we're actually making a new buffer every time, I think, or what we're doing. So yeah, we're making a new vector every time. But that's not the best thing ever, I guess. It would be, I guess, better if we like just make a buffer, right? And then you would essentially resize it. So instead of this, you would just say, let's see, or we could just call it, let's keep it as a buffer, okay. So now here we're just gonna say buffer.resize to message length as usize, and there you go. We're gonna make buffer mutable, and then we're gonna read exact mutable message, well, mutable buffer, right? Yes. And then from UTF-8 message, here we're trying to make a new string, interestingly. Buffer. Okay, that's fine, because we're gonna need to clone it anyways. After being moved, can't I just maybe say this? What? Expected VEQ8 values after being moved. So this actually moves it. Just why? Okay, so it seems like we have to do that anyways, apparently. That suck. But anyways, whatever. Okay, so now the thing is, I need to figure out how to actually make this asynchronous right now. But let's not think about that right now. I guess let's maybe make it more fun and maybe add some more stuff. I guess maybe we could add some messages that are like, let's say, we could either go with audio or images. Maybe images? No, hold on. Images or voice. I think voice would actually be nicer, crazier. But let's see. Godot voice recording. I think it's pretty simple using Godot though. Set recording active. Recording save to WAV. But yeah, before that we're gonna need to add some message type. So the message type would be an enum. So let's see. But actually I need to implement. But honestly, at this point, really, I'm quite tired already. That was a lot of debugging. I guess we're gonna continue maybe tomorrow again. So I don't know how much I've been. Okay, I've been streaming for 1 hour and a half again. But yeah, that was it, I guess, for this stream. Thanks for Isa Ismail, and Theo Paris, and Salim, Cyberus for tuning in to the stream. Thank you all guys for coming in. And see you later, everybody.